Hello everyone and welcome to another video of Special Maths Academy. In this video, we'll be looking at the 19th problem from the Special Maths contest as now to introduce the first round. And it says, find how many other pairs of positive integers and satisfy this beautiful looking equation here. 1 over m factorial plus 1 over n factorial equals to 1 over the LCM of m and n. Okay. So before I move into this question, please don't forget to subscribe, hit that subscribe button, share, like, and comment. And let's go into this problem. Okay. So first of all, we want to look at cases. So we want to find out cases that we can break this problem down into. Okay. So what are the cases we can break this problem down into? We can look at if m is equal to n. Okay. So if m is equals to n, or what do we have? If m is equals to n, we have, so we can just put here, so we have 1 over m factorial plus 1 over n factorial. Okay, so let me put m here. Plus 1 over m factorial equals to 1 over the LCM of m and m. Okay? So the LCM of m and m is going to be m. So in that case, we'll have 1 over m factorial. So times 2 equals to 1 over m. Okay? So I'll multiply through by m factorial. So we have 2 equals to m minus 1 factorial. Okay? That's when I multiply through. We have m factorial by m, which is just m minus 1 factorial. So for 2 to be equal to m minus 1 factorial, it implies that m minus 1 is equal to 2, because 2 factorial is 2. So I have m is equals to 3. Okay, so for the case of equality, we have one solution, so 3, 3. Okay, so I'll put this here and let's go to another case. So let me erase this. You can always pause the video to look at what we're doing. So how about the case when m is greater than n? Okay, so when m is greater than n, we can say m equals to n plus k, where k is greater than or equal to 1. Okay, since we're dealing with integers. Okay, so let's see what we have here. So we have 1 over, so we just put n plus k factorial. So 1 over n plus k factorial plus 1 over n factorial equals to 1 over LCM of n plus k and n. Okay, so uh we can multiply through um by n plus k factorial. But before we do that, something I want to state is, so if you have a times b, okay, so a times b is equal to the LCM of a and b, okay, times the GCD of a and b, okay. So in that regard, we can say that the LCM of a and b is equal to ab over the GCD of a and b. So we're going to be applying this identity here. Okay, so this is like a well-known identity. Okay, so let's move on. So we have 1 plus, so we have n plus k factorial over n factorial equals to, so I'm going to replace the LCM of n, 1 over the LCM of n plus k and n with this. So that would be GCD of n plus k and n all over n plus k times n. Okay, so that's what this 1 over LCM of n plus k and n is equal to. So then times n plus k factorial. Okay, so let me scroll down a bit. So what do we have here? We have 1 plus. So n plus k factorial over n factorial, that's just going to be n plus k, n plus k minus 1. So up to n plus 1. Okay. And then here we have, so this is going to be n plus k minus 1. Okay. So when you cancel out n, so we multiply up to n plus k minus 1, multiply up to n plus 1. Now, because we also have n in the denominator here, I'm going to skip n and then go to n minus 1 up to 1. So n minus 1 factorial. Okay. And times the GCD. So let's not forget the GCD. So n plus k and n. Okay. So let's call this oh, before I do that, let's simplify further. So we can say 1 is equal to, so we can take this to the other side, and we have a common factor here. So I'm going to write out the common factor. So I'm skipping some steps here. Sorry, this should be minus 2. N plus k minus 2. Okay. So n plus k minus 2 up to n plus 1. Okay. And then n minus 1 factorial times GCD of n plus k and n. Okay. Then minus, so minus n plus k. Okay. So we have this. So we have 1 is equals to this. Okay. So there's no way this is going to be possible because we have, so basically the only way this can be possible is if k is equal to 1. So let's look at it this way. If k is greater than 2, so if k is greater than or equals to 2, so let's try and get some contradiction. If k is greater than or equals to 2, then we have 1 equals to, so have uh, n plus k minus 1, n plus k minus 2 up to n plus 1 into n minus 1 factorial and GCD of n plus k n minus n plus k. Okay, so what we would have here, so let me scroll, would have that this number, so n plus k minus 1 up to n plus k times n plus k minus 2 up to n plus 1. What that this number will divide 1. Okay, and we know that so we know that this is at least n plus. So if k is greater than or equals to 2, we know that this is at least n plus 1. Okay, so we know that at least n plus 1 divides 1. Okay, so this gives a contradiction because no number apart from 1 divides 1. Okay, so what does this imply? It implies that k has to be equals to 1. Okay, so k has to be equals to 1. Okay, so since k has to be equal to 1, we can now like go back to our equation. Okay, let me make my writing thicker. So you can go back to our equation here and substitute k equals to 1. Okay, so let's scroll down a bit. So if we have k equals to 1, we have 1 is equals to, so since k is equal to 1, we would have okay, no. So let's go back to the original equation. So we have k equals to 1. Okay. So let me erase some things. So let me just erase some of these things down here to create space. Recall you can always pause the video and check what is being done. Okay, so let me, so I have n plus 1 factorial, and I have n, the LCM of n plus 1 and n. Okay, so recall that the LCM of n plus 1 and n is going to be equal to, so LCM of n plus 1 and n is equal to n into n plus 1. Okay, so why is that? Because the GCD of n plus 1 and n is equal to 1. Okay, and since the GCD of these two numbers is equal to 1, when we plug it into this identity we have here, we just have that it's going to be the product. So we have 1 over n plus 1 factorial plus 1 over n factorial is equal to 1 over n into n plus 1. Okay, so we can multiply through by n plus 1 factorial. So I have 1 plus n plus 1 is equal to, so we'll have n minus 1 factorial. Okay, so we have 1 plus n plus 1 is equals to n minus 1 factorial. So we have 2 plus n equals to n minus 1 factorial. Okay, so we have this factorial on the right-hand side and we have just a linear term on the left-hand side. So this grows very quickly. So we can quickly try to bound things. So let's just test some values. So if n is equals to 1, we have so 2 plus 1 and so 0 factorial. Okay, this does not work. If n is equals to 2, we have 2 plus 2 and so 2 minus 1 factorial, 1 factorial, this does not work. If n is equals to 3, we have 3 plus 2 and 3 minus 1 factorial is 2 factorial. This does not work. Okay, so let's scroll down. Oh, let me just erase this. Let me scroll down. Okay, so let's erase this. Let's keep testing more values. If n equals to 4, we have 4 plus 2 equals to 3 factorial. This works. So 4 plus 2 is 6, 3 factorial is 6. So if n is equals to 4. So n equals to 4 and m is equals to, so m is equals to n plus 1, which is 5. Okay. If n is equals to 5, we have 5 plus 2. So again, this is going to be an odd number equals to 4 factorial, which doesn't work. So here we can see that the factorial now begins to grow very, very quickly. So we see that the only solution, so we can inductively prove that factorial grows quickly. So the only solution is 4, 5. Okay, so we have 4, 5. And of course, because we're talking of ordered pairs, so we have 4, 5, 4, comma 5, and 5, comma 4. Okay, so we can actually, just plug it into check. So 1 over 4 factorial plus 1 over 5 factorial equals to 1 over LCM of 4 and 5. Okay, so let me erase some of this, just create space. 1 over 4 factorial is 1 over 24. 1 over 5 factorial is 1 over 120. Okay, this is equals to, so this is going to be 5 over 120 plus 1 over 120 is equals to 6 over 120, which is equals to 1 over 120. And we see that 20 is the LCM. So, yeah. So we have 3 tuples, and the answer is option C, 3. I hope you enjoyed this video. Don't forget to like, share, comment, and subscribe. And see you in the next video. Goodbye.